The next step in the security process is mitigation. So here what we want to do is we want to start thinking about specific ways to defend against attacks. One commonly used approach for this are called attack trees. When you're doing an attack tree, what you want to do is you want to think about who's trying to attack you, what they want, and what kinds of mechanisms they're going to use to accomplish their goal. For example, let's consider a curious attacker who just wants to see if they can gain access to a secured system. So in terms of mechanism, the first thing that they would probably try to do is try and guess the username and password of some valid user. Another attack might be to use a known vulnerability for the systems that that system is hosted on, right, on its underlying platform. Finally, the curious attacker might think about launching a phishing attack and trying to get someone who's already in the organization to inadvertently give them access to their system. By using an attack tree, we can then think of ways to harden these three mechanisms to make our system more resilient to a curious attacker who's trying to get at our system in one of these ways. Imagining the different ways the security of your system can be defeated is challenging. So engineers at Microsoft have invented this mnemonic called STRIDE, which gives us these different dimensions to consider. The first is spoofing. So in spoofing, an attacker will pretend to be someone else to gain access to your system. Then we have tampering. When someone tampers with your system, what they're going to do is they're going to log in or otherwise gain access to your system and modify it so it behaves incorrectly in the future. Repudiation means that an attacker will gain access to your system, defeat your security in some way, but then cover their tracks in a way that you can't figure out that you've been breached at all. Information disclosure is where an attacker gains access to our system and tries to extract information out of it that they shouldn't otherwise have. Next, we have denial of service. In denial of service attacks, an attacker's sole goal is to deny access to our system for other valid users. Right? The denial of service attack is a common network-based attack that really just seeks to make it look like our service isn't working at all. And finally, we have elevation of privilege, where an attacker gains access to our system but is able to increase their rights within the system to perform actions they shouldn't otherwise be able to do. And this is the classic root attack, where an attacker gets into your system with a low-level user account that perhaps has a weak password, and then manages to elevate their privileges into root level so they can do whatever they want with the systems that you're running. Minimizing our attack surface is one of the most common steps that we will undertake when we're thinking about mitigation strategies. The easiest way to think about this is in terms of the inputs that come into our system and the data that flows out, because attackers will use our input channels to gain access to the system, and we'll use our output channels to get data out of our systems. So what we want to do is we want to minimize these mechanisms as much as possible. So when we're thinking about those I/O mechanisms, what we want to do is we want to think about the code and systems that protect both the data that's coming into our system and the data that's flowing out. Right? So this will be code, authentication mechanisms, encryption, and that type of technology. We want to think about how we're securing those channels explicitly so we can really understand how an attacker will gain access to our platforms. When we're thinking about these input and output channels, what we want to do is we want to think about ways that those channels are being secured. So what is the code and underlying systems that will protect the data that's flowing into our system? What does our authentication mechanism look like? Are we using encryption? Is that data encrypted on our system so that it's harder to get at before it can be transmitted out? One thing to keep in mind, though, is that these thoughts are often strongly at conflict with functional goals of our systems, right? Because when you're thinking from a security point of view, you just want to lock everything down. But from a user's point of view, you want access to your systems so you can actually use them. So weighing the pros and cons of securing our systems can often be challenging and will involve deep conversations between various system stakeholders.